Hi students, welcome to Sangal Planning classes. In this session, we'll be discussing 3-mark questions of chapter integrals. So we have already discussed important concepts and we have discussed 1-mark and 2-mark questions. So straight away, we are going to discuss the questions. So the first question of today's session is, integral x by x plus 1 into x plus 2 dx. So mostly in this 3-mark session, the partial integration by partial fraction is asked. So we have already discussed how to find the integral using partial fractions, and we have discussed a table in the first class. So this was our table. If it was of the form px plus q by x minus a into x minus b, then we can split it like this: a by x minus a plus b by x minus b. Then if it is x minus a the whole square, then you should split this as how to make the partial fraction: a by x minus a plus b by x minus a the whole square. If it is of the form x minus a the whole square into x minus b, then a by x minus a plus b by x minus a the whole square plus the third term is x minus b. Alright, and if it is of the form some linear polynomial into a quadratic polynomial, then what should be the form of partial fraction? It is a by x minus a plus bx plus c by x square plus bx plus c. All right, now we are moving on to our questions. The first question is x by x plus 1 into x plus 2 dx. So here you can see that these two are polynomials and this degree is less than this one, right? And the denominator can be splitted into linear factors. So these are the conditions that we use to verify whether this is to be integrated using partial fractions or not. So all the conditions are satisfied. Now we can apply partial fraction, right? So how will you split this one? X by polynomial by linear factor, right? X plus 2. This can be written as a by x plus 1 plus b by x plus 2. A by x plus 1 plus b by x plus 2. All right. So this is equal to, from this x is equal to a into x plus 2. The denominator which is not present in below a, that is x plus 2, right? So a into x plus 2 plus b into x plus 1, b into x plus 1. This is how you write it. Right, now what I have to do is that you have to put some values for x. Put x is equal to minus 2. Now what happens if you put minus 2 here? This term gets cancelled, right? Only this term and this term remains. So x equal to minus 2 means minus 2 is equal to, here if you put minus 2, b into minus 2 plus 1, right? Minus 2 is equal to minus 2 plus 1 is minus 1. It is minus b. So b is equal to 2. B is equal to 2. Now put x equal to minus 1. Put x equal to minus 1. Here you put minus 1. So that is minus 1 is equal to, what happens there? This is a into minus 1 plus 2. Minus 1 plus 2. That is minus 1 is equal to a, that is a is equal to minus 1 and b equal to 2. A equal to minus 1 and b is equal to 2. Okay, now how can you rewrite this? How can you rewrite this one? This is integral x by x plus 1 into x plus 2 dx is equal to integral minus 1 by x plus 1 plus 2 by x plus 2 into dx. Okay, minus 1, a is equal to minus 1 and b is equal to 2, right? We have got b, the value of b is 2, right? A equal to minus 1. So integral minus 1 by x plus 1 plus 2 by x plus 2. Now if you split and find the integral, what happens? Integral, this is integral minus 1 by x plus 1 dx plus integral 2 by x plus 2 into dx, right? So if you take this minus 1 outside, this is integral 1 by x plus 1 dx plus 2 into integral 1 by x plus 2 dx. Okay, so this is equal to minus 1 into log mod x plus 1 plus 2 into log mod x plus 2 plus c. log mod x plus 2. Isn't it 1 by integral of 1 by x is x? Here it is a linear polynomial in place of x, so we can directly find the integral, but you have to divide the derivative. Here x plus 1, the derivative is 1. So instead of, if you divide or doesn't divide, doesn't matter, right? So this is equal to minus log a modulus of x plus 1 plus 2 log modulus of x plus 2 plus c. So this can be written as um, minus log, this 2 can be taken to this side, right? That is a log x can be written as log x to the power a, right? So this can be written as, this 2 log x plus 2 can be written as log mod x plus 2 square minus log mod x plus 1 plus c. Now we can use the property log a minus log b equal to log modulus of a by b, right? So this is equal to, this can be rewritten as log of modulus of x plus 2 square by modulus of x plus 1 plus c. Okay, now the second one is integral 2x by x square plus 3x plus 2 into dx. Okay, so this is 2x by x square plus 3x plus 2 can be written as 2x by, this one can be written as x plus 2. If you factorize this one, x plus 2 into x plus 1, right? So this can be written as a by x plus 2 plus b by x plus 1. A by x plus 2 plus b by x plus 1, right? So this is 2x is equal to a into x plus 1 plus b into x plus 2, right? Now what you have to do, put x equal to minus 1 first. You can make this term 0. So this is equal to 2 into minus 1 is equal to b into minus 1 plus 2. Okay, that is minus 2 is equal to b. So b is equal to minus 2. Now put x equal to minus 2. So that is 2 into minus 2 is minus 4. That is equal to a into minus 2 plus 1. That is minus a. So which means a equal to 4. A equal to 4 and b equal to minus 2. Right. So this is integral 2x by x plus 2 into x plus 1 into dx equal to integral 4 by x plus 2 plus minus 2 by x plus 1 into dx, x plus 1 into dx. So this is 4 into log mod x plus 2 minus 2 log mod x plus 1 plus c. Okay. I hope this question is also clear to you all. Now we are moving on to our third question. Integral 2x by x square plus 1 into x square plus 2 dx. Okay, here what I'm going to do is that I'm going to make a substitution. Okay, that is I'm going to put x square is equal to u. So 2x dx is equal to du. Now what happens here? This integral is 2x dx will become u, right? So this is, sorry, du. Now, this is u plus 1 into u plus 2. U plus 1 into u plus 2. Okay, so that is 1 by u plus 1 into u plus 2 is equal to a by u plus 1 plus b by u plus 2. A by u plus 1 plus b by u plus 2. So this is 1 is equal to a into u plus 2 plus b into u plus 1. A into u plus 2 plus b into u plus 1. Now what you have to do? You have to make any one 0, right? Any term 0. That if you put u equal to minus 2, what happens? 1 is equal to a into u plus 2 plus b into u plus 1, right? So if you put u equal to minus 2, this term gets cancelled, right? So that is 1 is equal to b into minus 2 plus 1, that is minus b, right? Which means b is equal to minus 1. We have got the value of b. Now you put u is equal to minus 1. u equal to minus 1 means this term becomes 0, right? Minus 1 plus 1 is 0. So that is 1 is equal to a into minus 1 plus 2. That is 1 is equal to, this is 1, minus 1 plus 2 is 1, right? A is equal to 1, a equal to 1 and b equal to minus 1. So integral 1 by u plus 1 into u plus 2 du can be written as integral 1 by u plus 1 plus minus 1 by u plus 2 into du. Okay, so this is equal to log mod u plus 1 minus log mod u plus 2 plus c. Okay, so that is log A minus log B is equal to log A by B. Right? So this can be written as log modulus of u plus 1 by u plus 2 plus c. And what is u? What is u? We have made a substitution. It is x square plus 1 by x square plus 2 plus c. Log mod x square plus 1 by x square plus 2 plus c. Alright. Moving on to our next question. That is fourth question. Prove that integral e raised x into f of x plus f dash of x into dx equal to e raised x into f of x plus c. So these type of questions that this rule is applicable are we have discussed in 1 mark and 2 mark section. So this is actually proving that result, that is e raised x into f of x plus f dash of x dx is in general the result is e raised x into f of x. That is what we have to prove here. All right. So here I'm going to take this one as I. I equal to, let this one is I equal to e raised x into f of x plus f dash of x dx. All right. Now we can split this one. E raised x into f of x dx plus integral e raised x into f dash of x dx. First you split this, open the bracket and then you separately put the integrals. Okay, I have done both the steps in a single step. Okay. So let this be I1. Okay, let this be I1. I1 plus integral e raised x into f dash of x dx. All right. Now, what I'm going to do is that I'm going to separately find the I1. I1 was integral e raised x into f of x dx. And we know here if you have a product of two functions, then we have to follow the Eilert rule. So here one is exponential and the f of x means it's algebraic expression, right? So polynomial. So this the order should be rearranged. That is f of x, integral f of x into e raised x dx, because exponential term comes last according to the priority, right? So this is equal to first into integral of second function minus integral of derivative of first function into integral of second function. This is the part rule, integration by parts rule, right? So this is equal to f of x into e raised x itself, right? Minus what is derivative of f dash of x? It is integral f dash of x, then integral, it is integral f dash of x, then integral e raised x is e raised x itself, right? So it is e raised x dx, e raised x dx. All right. Now plus c. There is always a constant of integration. Now what I'm going to do is that I'm going to consider I and put this one over there. I1 plus integral e raised to x into f dash of x dx, right? So I'm going to make the substitution over there. That is f of x into e raised to x minus integral f dash of x into e raised to x dx plus c plus the second term was e raised to x into integral e raised to x into f dash of x dx. So here you can see that these two terms gets cancelled. So what is remaining here? E raised to f of x plus c. E raised to f of x plus c. So what is I is equal to e raised to integral e raised to x into f of x plus f dash of x dx. So that was e raised x into f of x plus c. E raised x into f of x plus c. Okay. Now, moving on to our fifth question. Okay. E raised x into 1 plus sin x by 1 plus cos x dx. Okay. So here, what I'm going to do is that I'm going to let this be I. So this is integral e raised x and 1 plus sin x. Sin x I'm going to write, sin 2x is equal to 2 sin x. There is an identity. 2 sin x cos x. So what is sin x? This is half angle, half of 2x, right? So this one will be 2 sin x by 2 cos x by 2, right? So 1 plus 2 sin x by 2 cos x by 2 divided by, now 1 plus cos x. 1 plus cos x, we can write it as 2 cos square x by 2. 1 plus cos 2x is 2 cos square x. So 1 plus cos x is 2 cos square x by 2, right, into dx. So we have applied trigonometric identities here. Now we can cancel this cos x by 2. I'm sorry, I'm really sorry. You can cancel it directly from there. Now we can split this one, right? This is equal to integral e raised x into 1 by 2 cos square x by 2 plus 2 sin x by 2 cos x by 2 divided by 2 cos square x by 2. That is, we are splitting the denominator to each part of the numerator. All right. So this is equal to integral e raised x into 1 by 2. What is 1 by cos square x by 2? It is sec square x by 2. Sec square x by 2 plus 2 gets cancelled. Cos x by 2 and 1 cos x by 2 gets cancelled. What is remaining there? Sin x by 2 divided by cos x by 2. What is sin by cos? It is tan, right? So this is equal to tan x by 2. Tan x by 2 into dx. It is equal to tan x by 2 into dx. And now you can observe this. um, that is d by dx of tan x by 2. What is it? Tan x by 2, we know it is sec, tan x, we know it is sec square x derivative, right? So here it is sec square x by 2, but we have considered x by 2 in the place of x. So we have to multiply the derivative is 1 by 2, so it is 1 by 2 sec square x by 2. So this is f of x. If this is f of x, then what is f dash of x? F dash of x is equal to 1 by 2 sec square x by 2. Now what we have got there over there, that was I equal to e raised x into 1 by 2 sec square x by 2 plus tan x by 2 into dx. This was our last step, right? So if you compare, what is this? This is equal to integral e raised x into this one is f dash of x and the second term is f of x, right, into dx. So have you familiar with this one? We have already proved in the earlier problem, right? This is equal to, this is nothing but e raised x into f of x plus c. So here what is f of x? E raised x into f of x is nothing but tan x by 2 plus c. E raised x into tan x by 2 plus c. All right. Moving on to our next question. Integral 0 to pi by 2 cos square x dx. Integral 0 to pi by 2 cos square x dx. Okay, so let I be integral 0 to pi by 2 cos square x dx. Let this be 1. Okay, so this can be written as 0 to pi by 2 cos square of pi by 2 minus x. Cos square of pi by 2 minus x dx. Okay, so what is cos square of pi by 2 minus x? What is cos square of pi by 2 minus x? It is nothing but sine square x, right? It is sine square x. So 0 to pi by 2, 0 to pi by 2, sine square x dx. So this is our second one. Let this be a second equation. So if you add 1 plus 2, from 1 plus 2, you get from 1 plus 2, I plus I is equal to integral 0 to pi by 2 cos square x plus sine square x into dx. Cos square x plus sine square x into dx. Alright. So this is equal to, you need to know the properties of definite integrals. Okay. So this is equal to integral 0 to pi by 2 1 dx. Okay. So that is, what is integral 1? It is x. X evaluated from 0 to pi by 2. What is it? Pi by 2 minus 0 is pi by 2. So 2i, that is 2i is equal to 2i is equal to pi by 2. So what is I? I is equal to pi by 2 into 1 by 2. That is pi by 4. What is the value of I? I is equal to pi by 4. Alright. Now, moving on to our next question. Integral integral x into tan inverse x dx. So again, it's a product of two functions. So what we have to do here, we have to check whether it follows the Eilert rule. Whether it follows the Eilert rule. Okay, that is x into tan inverse x, right? X into tan inverse x. X is the algebraic function. Tan inverse x is an inverse function. So if you observe the Eilert rule, inverse function should come first, right? So which means this should be rearranged as integral tan inverse x into x dx. Tan inverse x into x dx. Okay. So this is equal to first function into integral of second function minus integral of derivative of first function into integral of second function. That is tan inverse x into x square by 2 minus derivative of tan inverse x. What is the derivative of tan inverse x? It is 1 by 1 plus x square into x square by 2 dx. Right? So this is equal to tan inverse x into, and this 1 by 2 can be written like this also, into x square minus 1 by 2 integral x square by 1 plus x square dx. Right? Integral x square by 1 plus x square dx. Now what I'm going to do is that I'm going to make a substitution. Okay? I'm going to make a substitution here. Not a substitution, some changes like this minus 1 by 2 integral. I'm going to add 1 and then subtract that minus 1. Then only it will be equal, right? In the numerator, then it will be like this. And now what I'm going to do is that this is 1 by 2 into x square into tan inverse x. There is no change in that term. But here, I'm going to split this 1x square plus 1 by 1 plus x square. Both are same, right? And then minus 1 by 1 plus x square. I just splitted it. Okay, I just splitted it. So this will become 1. This term will become 1. So this is same, but this term will become 1 minus 1 by 1 plus x square dx. Right? So what is the integral? This is 1 by 2 x minus 1 by 1 plus x square is tan inverse x, right? Tan inverse x, plus c. Okay, so what is the integral? 1 by 2 x square tan inverse x minus 1 by 2 into x minus tan inverse x plus c. X minus tan inverse x plus c. Alright. I hope this question was clear to you all. Moving on to our next question. So this is 3x minus 1 by x minus 1 into x minus 2 into x minus 3 dx. So this can be splitted by using partial fraction as x minus 1 into x minus 2 into x minus 3 is equal to a by x minus 1 plus b by x minus 2 plus c by x minus 3. Right? So 3x minus 1 is equal to a into x minus 2 into x minus 3 plus you write the denominator which is not present in that particular one. If you're considering a, you don't write, you don't find the product with the denominator of a. All the rest denominator you can write. So this is b into then x minus 1 and x minus 3. Okay, x minus 1 into x minus 3 plus c into x minus 1 into x minus 2. Okay, so the peculiarity here is that there are three factors. That's what the difference is here in here, this question. So this is, if you put, writing that previous step again, a into x minus 2 into x minus 3 plus b into x minus 1 into x minus 3 plus c into x minus 1 into x minus 2. All right. So the if you put x is equal to 2, put x equal to 2. 2 means if you put 2 here, this and this term gets cancelled. This it will become 0, right? So what is remaining there? 3 into 2, 6 minus 1 is equal to b into 2 minus 1 into 2 minus 3. So what is the answer? 5 is equal to 2 minus 1 is 1, 2 minus 3 is minus 1. So it is minus b. So b is equal to minus 5. Now put x is equal to 3. Okay, put x equal to 3. So what happens? This one becomes 0 and this one becomes 0. So 3 into 3, 9 minus 1 is equal to c into 3 minus 1 into 3 minus 2. Alright, so this is 8 is equal to 3 minus 1 is 2 and 3 minus 2 is 1. So 2c. So what is the value of c? C is equal to 8 by 2 equal to 4. Now you put x is equal to, x is equal to 1, right? We haven't put x equal to 1. So 1, then this term gets cancelled and this also gets cancelled. Only this term will be remaining. So this is equal to 3 minus 1 is equal to a into 1 minus 2 into 1 minus 3. So this is 2 is equal to 1 minus 2 minus 1. 1 minus 3 is a into minus 1 into minus 2, which means it is 2a, right? That is 2a is equal to 2. So a is equal to 1. What is the value of a? A is equal to 1. We have got the value of a, b and c. We have got the value of a, b and c, right? So this is equal to integral 3x minus 1 by x minus 1 into x minus 2 into x minus 3 dx is equal to integral of 1 by x minus 1 plus b is minus 5 by x minus 2 plus 4 by x minus 3 into dx. So this is equal to log mod x minus 1 minus 5 log mod x minus 2 plus 4 log mod x minus 3 plus c. Okay, so this is the answer of that question. Moving on to our next question. So in this session, the most important thing that you have to know is integration by partial fraction. Most of the questions are from that session. Okay, so make it thorough by doing different problems. Okay. Then next question is integral x by x minus 1 the whole square into x plus 2 into dx. Integral x by x minus 1 the whole square into x plus 2 dx. So this is x by x minus 1 the whole square into x plus 2 is equal to a by x minus 1 the whole square plus, I'm sorry, there is one more term, right? First, you have to split it like a by x minus 1 plus b by x minus 1 the whole square. This is how you have to make this type of function into partial fraction, right? If x minus 1 the whole square into x plus 2 comes, what you have to do? A by x minus 1 plus b by x minus 1 the whole square plus c by x plus 2. So this is the thing that you have to know here, how to split or how to make it into a given function into partial fraction. Okay, that is very important solving these type of questions. All right. So here also we have to find out the values of a, b and c. For that we have to, first we have to make this one as a into x minus 1 the whole square, um, a into x minus 1 the whole square into x plus 2 plus b into x minus 1 into x plus 2 plus c into here the thing is that you just when you make it when you split it like this, you have to do is that you just consider which is not present here. Okay, which is not present here. X minus a by x minus 1 is present there, right? X minus 1 is a factor, right? So you have to remove that one. So which is not present over there, it is x minus 1 and x plus 2. So this is a into x minus 1 into x plus 2. Okay, plus b into, here x minus 1 the whole square is completely present. So what is not there? It is x plus 2, right? It is x minus 1 and x minus 1. X minus 1 the whole square means x minus 1 is a factor, right? So you don't need to write this one. So this is x plus 2. Then plus c into x plus 2 is a factor. Then which all will be there? It is x minus 1. The whole square is not present. X minus 1 into x minus 1. X minus 1 the whole square. Okay, this is how you have to split it. Right. Now what you have to do is that you have to put the values and check. So first of all, we can write it again. X equal to a into x minus 1 into x plus 2 plus b into x plus 2 plus c into x minus 1 the whole square. Okay, this is how you write that. So this is equal to, put x is equal to, put x is equal to 1. First you put x equal to 1. Now what happens? This term and this term will become 0. So what is it? 1 is equal to b into 1 plus 2. That is 3b is equal to 1. b is equal to 1 by 3. We have got the value of b. Okay. Now put x is equal to, put x is equal to minus 2. Put x equal to minus 2. Okay, so if you put x equal to minus 2, now what happens? If you put x is equal to minus 1 by 2. Okay, so I'm sorry, minus 2. X equal to minus 2 means this term and this term gets cancelled, right? So what is remaining? C term only remaining. Minus 2 is equal to C into minus 2 minus 1 the whole square. So that is minus 2 is equal to C into minus 3 the whole square. That is minus 2 is equal to C into 9. That is C is equal to minus 2 by 9. C is equal to minus 2 by 9. Okay, so we have got the value of C. We have got the value of C. Now equating coefficients of x square. Equating coefficients of x square in order to find a. Okay, we are equating the coefficients of x square. We know left side the coefficient of x square is 0. There is only x term, right? So the coefficient is 0 in the left side. And what all will be there in the right side? In the right side, this is our equation, right? You can see this is our equation. So x into x square, which means a will be a coefficient. There is no x square term here. Here also there will be an x square term. What is the coefficient of it? It is c, right? So this is equal to A plus C, right? And we have got the value of C. C is equal to A minus 2 by 9, right? So what is A? A is equal to 2 by 9. We have got the values of A, B and C, which means integral x by x minus 1 the whole square into x plus 2 into dx can be written as integral 2 by 9 by x minus 1 plus 1 by 3 by x minus 1 the whole square plus minus 2 by 9 by x plus 2 into dx. So this is equal to 2 by 9 log mod x minus 1 plus 1 by 3 into this is actually integral of 1 by x square. It is minus 1 by x, right? But here it is here it is x square, right? So this is equal to 1 by 3 we can take it outside, and this one will be equal to minus 1 by x minus 1 because we have to divide the it is actually integral 1 by x minus 1 the whole square, right? Integral 1 by x minus 1 the whole square. So if you compare it this one, you'll get it as minus 1 by x minus 1, right? So this is minus 1 by x minus 1 by x minus 1, then minus 2 by 9 into log mod x plus 2 plus c. Okay, now you can group it and write it as 2 by 9 log mod x minus 1 minus 1 by 3 into x minus 1 minus 2 by 9 log mod x plus 2 plus c. Okay, so this is the answer for that particular question. And now integral x by x square plus 1 into x minus 1 into dx. Okay, so that is x by x square plus 1 into x minus 1 is equal to, we can split this as, actually this one is a second degree polynomial, right? So how will you split into partial fraction ax plus b by x square plus 1 plus c by x minus 1. This is how you have to split it. Now what is it? X is equal to ax plus b into x minus 1 plus c into x square plus 1. Okay, now what you have to do? You have to put x equal to, first you put x equal to 1, then this term will become 0, right? Put x equal to 1. So 1 is equal to here c into 1 plus 1, that is 2c. 1 is equal to 2c, c is equal to 1 by 2. C is equal to 1 by 2. Okay, now what you have to do is that you put x equal to 0. So before that you put you equate the coefficients of x square. Okay, equate coefficients of x square. Okay, equating coefficients of x square means in the left side we know there is no x square term, there is only an x term, so the coefficient of x square is 0. Then here you can see ax into x, right? So there will be a coefficient, the a will be a coefficient. Then you can see that c into x square. So the coefficient of x square will be c also. So a plus c. And what is a? A is equal to 1 by 2. 1 by 2 plus a, right? Which implies c is equal to minus 1 by 2. C is equal to minus 1 by 2. Now put x equal to 0, x equal to 0. So 0 is equal to, this term is equal to 0, a into 0, right? Then plus b only will be there. Then 0 minus 1 is minus 1. So it is equal to minus b. Now if you put 0 here, what happens? 0 plus 1 is 0. Sorry, 1. 1 into c is c. So minus b plus c. So this is actually minus b equal to minus c. So which means b equal to c. And c we have got it as minus 1 by 2. So b is also minus 1 by 2. So we have got all the values a, b and c. We have got all the values a, b and c. Now we can substitute in the formula. That is integral x by x square plus 1 into x minus 1 dx is equal to integral ax plus b. So a is minus 1 by 2 into x plus 1 by 2 by x square plus 1 plus 1 by 2. C is 1 by 2, right? 1 by 2 by x minus 1 dx by x minus 1 dx. Now what you have to do? You can split this one. Minus 1 by 2x by x square plus 1 plus 1 by 2 divided by x square plus 1 plus 1 by 2 divided by x minus 1 into dx. If you take this minus 1 by 2 outside, this is integral x by x square plus 1 into dx plus 1 by 2 integral 1 by x square plus 1 into dx plus 1 by 2 integral 1 by x minus 1 into dx. Okay, here you can see that there is a deficiency of 2 here, because if you consider this as f of x, then the derivative is of that function is 2x, right? But here in the numerator there is only x. So what you have to do, you have to put a 2 over there. That is, you multiply a 2, then you should definitely divide also it with 2, right? So this will be, so this is of the form, this will be of the form f dash of x by f of x. Then uh, this has become f dash of x by f of x form. So it is log mod f of x, right? The answer will be log mod f of x, right? So this is equal to minus 1 by 4 log mod x square plus 1 plus 1 by 2. This is 1 by x square plus 1. 1 by 1 plus x square. It is tan inverse x, right? Tan inverse x plus 1 by 2. This is 1 by x is log x. 1 by x minus 1 is log x minus 1. And the derivative of x minus 1 is x is 1 itself. So dividing it with 1 is same, right? Plus c. Plus c. So this is the answer. Okay. So moving on to the last question of the session. Okay, so these type of questions you have to practice it with different problems. Okay, the type of question, but with different values. Okay, different functions. You have to try it. Then the last one is integral 3x plus 5 divided by x cube minus x square minus x plus 1 into dx. Okay, so this can be written as integral 3x plus 5 divided by, I'm taking x square outside from the first and two terms. Okay, that is x square into x minus 1 minus x and minus x plus 1 can be written as minus of x minus 1 into dx. Now what I'm going to do is that 3x plus 5 divided by, or make a rearrangement. That is x minus 1 take outside. So what is remaining? X square minus 1 into dx. And this is of the form a square minus b square. Right? What is it? A minus b into a plus b. Right? So integral 3x plus 5 divided by x minus 1 into x minus 1 into x plus 1. Okay? Dx. So this is actually integral 3x plus 5 divided by x minus 1 the whole square into x plus 1 dx. Now we can apply partial fraction, right? Now we can apply partial fraction. We have done such a problem earlier, but again we can do it. 3x plus 5 by x minus 1 the whole square into x plus 1 is equal to a by x minus 1 plus b by x minus 1 the whole square plus c by x plus 1 plus c by x plus 1. Okay, so that is 3x plus 5 is equal to a into x minus 1 is over there. So this is x minus 1 into x plus 1. What is left is x minus 1 and x plus 1 plus b into x minus 1 the whole square is there. So just multiply it with x plus 1. Then plus c into x plus 1 is already there. So what is left? It is x minus 1 the whole square. X minus 1 the whole square. Okay. So if you are getting confused, then you check it with here, okay, while multiplying a, b and c. Okay. So this is now what you have to do, you have to find out the values of a, b and c. For that, put x is equal to, first you put x equal to 1. So this one will be equal to 3 plus 5, that is 8. 8 is equal to, if you put 1 here, this will get cancelled and this will get cancelled, only this one will be there. Right, b into x plus 1. So b into 1 plus 1 means this 2b. 2b equal to 8. b is equal to 8 by 2 equal to 4. So we have got the value of b. Now put x is equal to minus 1. Put x equal to minus 1. Minus 1 means minus 1 plus 1. This term gets cancelled. This term gets cancelled. Only this one will be pending. Right? So minus 1 means minus 3 plus 5. Right? Minus 3 plus 5 is equal to c into minus 1 the whole square. So this is actually 2 is equal to minus 2 the whole square means it is 4. Right? 4c. So what is c? c is 4 by 2 equal to 2. C value of c is equal to, I'm sorry, it is 2 by 4, right? 2 by 4, 2 by 4 is equal to 1 by 2. 2 by 4 is equal to 1 by 2. Now put x is equal to 0. Put x equal to 0, okay? So if you put x equal to 0, what happens? This one will become 0. So 5 into, this is 0 minus 1 into 0 plus 1. So it is minus a. Then 0 plus 1 is 1. 1 into b is plus b. 0 minus 1 is minus 1. The whole square is 1. So it is plus c. And we know the values of b and c, right? So this is equal to minus a plus 4 plus 1 by 2, right? So what is minus a? Minus a is equal to 5 minus 4 minus 1 by 2. Right. 5 minus 4 minus 1 by 2. 5 minus 4 is 1. 1 minus 1 by 2 is 1 by 2. Minus a is 1 by 2, which implies a is equal to minus 1 by 2. We have got minus a is 1 by 2. So a, what is the value of a? A is equal to minus 1 by 2. So we have got all the values a, b and c. Now what you have to do? You have to just put there, that is integral 3x plus 5 divided by x minus 1 the whole square into x plus 1 into dx is equal to integral of minus 1 by 2. Isn't it? Minus 1 by 2 by x minus 1 plus b by x minus 1 the whole square, right? Plus c was 1 by 2 by x plus 1 into dx. Okay, so this is equal to minus 1 by 2 log mod x minus 1, right? Plus 4 into 1 by x square. What is the integral of 1 by x square? It is minus 1 by x, right? Here it is in the place of x, it is x minus 1. It is a linear polynomial. It is a linear polynomial, right? Linear polynomial. So what is the derivative of it? X minus 1 is, derivative is 1, right? So it is minus 1 by x minus 1. So this is equal to into minus 1 by x minus 1 plus 1 by 2 log mod x plus 1 plus c. Log mod x plus 1 plus c. So this can be written as, we can rearrange this, right? So this can be written as minus 1 by 2 log mod, or you write this one first, 1 by 2 log mod x plus 1 minus 1 by 2 log mod x minus 1, then minus 4 by x minus 1 plus c. Okay, so this can be written as 1 by 2 log, 1 by 2 is common, so we can take outside, right? Log mod x plus 1 by x minus 1. Property of log a minus log b is log a by b, right? So this is minus 4 by x minus 1 plus c. So this is the answer of that particular question. Okay, so we have covered almost all the pattern of questions or type of questions that are asked in 3-mark session. I hope this session was useful to you all. So practice with more problems from your textbook itself. Okay. And then only you will get you'll increase the speed also. All right. So I hope this session was useful to you all. So until then, bye.